Welcome to ECO 442, Study Session 11, Network Analysis. Introduction. In this lecture, you'll be examining the management techniques developed to aid management in the planning and control of projects, which is usually referred to as network analysis. These techniques show the interrelationship of the various jobs or tasks which make up the overall project and clearly identify the critical parts of the project. Objective. At the end of this lecture, you should be able to construct a network diagram and perform related calculations. A. Nature of network analysis. Network analysis is an important concept that deals with project management. A project is a well-defined set of jobs, tasks, or activities which must be completed in a specified time and sequence order. The jobs, tasks, or activities are interrelated and require resources such as money, material, personnel, and other facilities. Therefore, the major focus of project management is to schedule jobs, tasks, or activities in an efficient way so as to reduce or have minimum cost of its completion within the specified period. Alternative reference names for network analysis include network planning and scheduling techniques, critical path analysis, CPA, critical path planning, CPP, critical path scheduling, CPS, critical path method, CPM, and program evaluation and review technique, PERT. Possible areas of application of network analysis include construction projects such as building highways, house, bridge, etc., maintenance or planning of oil refinery, ship repair and other large operations, preparation of bids and proposals for large projects, development of new weapon or system or manufacturing system, manufacturing and assemblage of large items such as airplanes, ships, and computers, and simple projects such as home remodeling, moving to a new house, house cleaning, and painting. B. Some important terminologies. Activities. An activity represents an action, project operations or task, which is time and resource required effort to complete a particular part of an overall project. It incurs cost and has a point of time where it begins and a point where it ends. Hence, an arrow symbol is usually used to represent an activity. Dummy activity. This is an activity which carries zero duration because it does not consume either time or resource. The symbol commonly used for this is the arrow with dotted line. The two main reasons for using dummy activity are to present the logical sequence of activities and the unique activity numbering system. Event. An event represents the start or completion of an activity or task and as such does not consume time and resource. Hence, it can be said to be scientific instance of a time that denotes the beginning or end of an activity. It is usually represented by a cycle, as noted in the network diagram. Events can be further categorized into burst or merge type. When an event is the starting event of two or more activities, it is called burst event. while an event, which is ending event of two or more activities, is called merge event. They are both depicted below. Network diagram. The diagrammatical representation of the network techniques, which consists of arrows, activities, and nodes, events, is known as network diagram. Network diagram is the combination of activities, dummy activities, and events in logical sequence according to the rules for drawing network. Thus, a small network might appear as follows. There are two types of precedence network models, which are the activity on arrow AOA network model and the activity on node AON network model. The activity on arrow AOA network is the most popular method of network analysis and shall be used more in this lecture. In arrow diagram, the network is drawn by putting the various activities of the project on arrows which are arranged in logical sequence. Every event is assigned a number which is placed inside the cycle. Note: the number sequence allows the flow of network. The arrow diagram has a single starting node from which all activities with no predecessors may begin and then work its way left to right by ending with single node. In the AON model, the name of activity and its duration are usually placed within the nodes. The arrows are used to indicate the sequencing order requirements of the tasks or jobs. This approach eliminates the problem of using dummy activities. It has no particular starting and ending event nodes for the entire project. C. Example 1. Consider 6 jobs or tasks A, B, C, D, E, F of a project with the following job sequence. Job A precedes B and C. Job B precedes D. Job C and D precedes E. Job E precedes F. You are required to draw network diagram for this problem using activity on arrow method, activity on node method. E. Methods of network analysis. The two well-known methods of network analysis are 1. Critical path method CPM and 2. Program Evaluation Review Technique PERT. Both methods CPM and PERT focus their procedures on identifying the critical path. The critical path takes the longest or maximum time duration of the project, while activities on the critical path are called the critical activities. Major features of CPM. 1. CPM is used for activities which are deterministic. 2. It is an activity-oriented technique. 3. It is good in establishing a trade-off for optimum balancing between scheduled time and cost of the project. And 4. CPM was developed mostly for maintenance and construction projects. Major features of PERT. 1. It is an event-oriented technique. 2. It handles probabilistic type of data. And 3. It has activities of non-receptive nature and therefore used for one-time projects. F. CPM procedure. The procedure of identifying the critical path in the CPM involves 3 phases. These phases are 1. Forward pass computations, earliest start time. 2. Backward pass computations, latest start time. And 3. Float slack computations. earliest start time (EST) forward pass. It is possible to assess the total project time by calculating the EST for each activity. The EST of a head event is obtained by adding onto the EST of the tail event the linking activity duration starting from event 0, time 0, and working forward through the network. Where two or more routes arrive at an event, the longest route time must be taken. The EST in the finish event is the project duration and is the shortest time in which the whole project can be completed. Steps for calculating forward pass. Step 1. Set EST 0 equals to 0 to indicate that the project starts at time 0. Step 2. Obtain the next ESTJ by the general formula. ESTJ equals to maximum of all ESTJ plus T high for all routes I leading to event J. And if there is only one route to event J, it simplifies to ESTJ equals to EST high plus T high. When T high is the time to reach event J from route high. Latest start time LST backward pass. The LST is the latest possible time at which a preceding activity can finish without increasing the project's duration. Starting at the finish event, insert the LST, the finish LST, and work backwards through the network deducting each activity duration from the previously calculated LST. Where two tails of activities join one event, the lowest number is taken as the LST. Along the critical path, EST equals to LST. Steps for calculating forward pass. Step 1. Set LSTN equals to ESTN. Step 2. Obtain the next LSTJ by the general formula. LSTJ equals to minimum of all LSTJ plus TJJ for all routes I leading from event J. And if there is only one route leading from event J, it reduces to LST high equals to LST high plus T I high. Float slack computations. The term float or slack refers to the period of time by which a particular activity or event can be delayed without the time schedule of the network affected. The term float is referred to CPM when activities are considered, while PERT goes with slack when events are involved. The non-critical activities have time or floats. If it is required to reduce the overall project duration, then the time of one or more of the activities on the critical path must be reduced, perhaps by using more labor or more better equipment or some other methods of reducing job times. Total float is the amount of time a part of activities could be delayed without affecting the overall project duration. Total float equals to latest head or finish time minus LS tail or finish time minus activity duration. Free float is the amount of time an activity can be delayed without affecting the commencement of a subsequent activity at its LS start time, but may affect float of a previous activity. Free float equals to LS edge time minus LS tail time minus activity duration equals to EFT minus EST minus D. Independent float is the amount of time an activity can be delayed when all preceding activities are completed as late as possible and all succeeding activities are completed as early as possible. Independent float equals to LS edge time minus latest tail time minus activity duration equals to EFT minus LST minus D. Slack is the difference between the EST and LST for each event. Events on the critical path have zero slack. Alternative methods of obtaining critical paths. It is possible to obtain the critical path without using the float slack approach. All that is needed is to draw first the network diagram and then list out all possible routes in network. Compute the total days for each route and then pick the route with the highest total as the critical path. G. Example 2. An electrification project in Thai village has to pass through 6 tasks. The duration and the precedence order of these tasks are given below. You are required to 1. Construct the network diagram for the project. 2. Determine A. The forward passes, B. The backward passes, C. The float, and hence the critical path. H. Solution 2. See figure 1. 2. A. The forward passes can be obtained as follows. EST0 equals to 0, EST1 equals to EST0 plus TOI equals to 0 plus 14 equals to 14 days. EST2 equals to EST1 plus T12 equals to 14 plus 18 equals to 32 days. EST3 equals to EST1 plus T13 equals to 14 plus 16 equals to 30 days. EST4 equals to max EST2 plus T24, EST3 plus T34 equals to max 32 plus 17, 30 plus 15 equals to max 49, 45 equals to 49 days. EST5 equals to EST4 plus T45 equals to 49 plus 15 equals to 64 days. 2b. The backward passes can be obtained. LST5 equals to EST5 equals to 64 days. LST4 equals to LST5 minus T45 equals to 64 minus 15 equals to 49 days. LST3 equals to LST4 minus T34 equals to 49 minus 15 equals to 34 days. LST2 equals to LST4 minus T24 equals to 49 minus 17 equals to 32 days. LST1 equals to mean LST2 minus T12, LST3 minus T13 equals to mean 32 minus 18, 34 minus 16 equals to mean 14, 18 equals to 14 days. LST0 minus LST1 minus T01 equals to 14 minus 14 equals to 0 day. 2c. The floats are calculated as follows. Thus, the critical path is 0 minus 1 minus 2 minus 4 minus 5 with activities A minus C minus E minus F. The critical length 14 plus 18 plus 17 plus 15 equals to 64 days. 3. Critical paths from possible routes. H. Solution 2. 1. PERT procedure. In CPM, it is assumed and known that the duration of activities is deterministic and of a single time estimate. But for PERT, it is probabilistic and activity is based on 3 time estimates of performance. That is, optimistic 0, most likely ML, and pessimistic P. These 3 estimates are combined to give an expected time, and the accepted formula is expected time equals to 0 plus P plus 4 ML over 6 Time estimates may be given in any units, that is, minutes, hours, days, weeks, depending on the project. All times estimates within a project must be in the same unit. After you have obtained the expected time for each activity, you then apply the same procedure of obtaining forward pass and backward pass in CPM to obtain the critical path. J. Example 3. You are given the following information about project X26. Using the above information, you are required to 1. Draw a network diagram for the project. 2. Draw another network diagram with EST and LST values. 3. Calculate the float for each activity. 4. Calculate the slack for each event. 5. Identify the non-critical chain and calculate the total float over the chain. K. Solution 3. See figure 1. A. The events have been numbered from 0, the start event, to 7, the finish event. B. A dummy 3 to 6 is necessary because of the preceding activity requirements of activity L. If EH had not been specified as preceding activity L, the dummy would not have been necessary. C. The shape of the network is unimportant, but the logic must be correct. 2. See figure 2. Critical path equals to A minus C minus G minus L minus N. 3. Calculation of floats. 4. Calculations of slack over the event. Critical event path 0 minus 1 minus 4 minus 6 minus 7 minus 8. 5. Total floats along the non-critical chain. Summary. Network analysis is a technique that aids management in the planning and control of projects. In two methods are the CPM and PERT, which all focus on identifying the critical path. The critical path is the longest route of the project. The procedure of identifying the critical path in the CPM involves the calculation of forward pass, early start time, backward pass, later start time, and float slack. The PERT method is based on 3 time estimates: optimistic O, most likely ML, and pessimistic P. End of study session 11. Thanks for listening.